Hello everyone, thanks for coming, and thanks to the organizer for putting together this very interesting conference. I'm going to present a project that I'm working on at the Bank of England with some colleagues. Obviously, this is our own research work. I mean, there's the usual disclaimer, these are not the views of the Bank of England. And this is, as I said, a work in progress project to use some data that are available to estimate something that we currently don't have, good indices of land prices in the UK. Let me say straight from the beginning that we use some Python in the project, but the presentation is more about the data and what's available out there and the conclusion we can draw from the data rather than Python techniques, Python code. So if you want to leave, don't worry. Okay, so let me start by this, right? These are house prices in England and Wales for the last 20 years, and these are clearly important variables to take into account, mostly because if we take the wealth of households, house is the biggest asset, the biggest element for those households, especially in the United Kingdom. If we take banks' balance sheet, we have the same thing. Houses are the most important item. However, maybe one point that is known, but perhaps not discussed enough, is the fact that you can always conceptualize a house as a bundle of two different things. One is a structure or a building, and the other element is the land beneath it. Why this is interesting? Because structure is reproducible. You can always build the same structure somewhere else. Land is not. Land is unique. And also from this translates to some interesting macroeconomic facts that make land prices more interesting than structure prices. So here I kept the house price index that I showed before. It's the dashed line on an annual basis, and in red I plotted building costs for the UK in the same period. And as you can see, building costs, yes, are increasing, but they have a much smoother pattern over the years, because basically they depend on the salary of builders and the cost of materials. So it's more like an inflation type of series, whereas the booms and busts that we are used to see in the housing market, they certainly don't come from building costs. This means that if a house is structure plus land, it must be that land is the more volatile of the two elements. Indeed, if we keep the same series as before, house prices, but we now compare house prices to land prices, in the red, on the red line, we see that land prices were very volatile in the run-up to the housing boom and in the subsequent crash. So land prices, if land prices, we give them a value of 100 in 1995, they went up to more than 500 at the peak of the boom. Now, the interesting thing in this graph is that the series for land prices stops in 2010. Why? Because the Valuation Office Agency, who was in charge of producing this series, stopped doing so. And this, for many people, has been a problem since then. Here I have quoted an open letter to the government of 2013 by a former member of the Bank of England Monetary Policy Committee, a professor from the London School of Economics, and there were other people who signed. And they say, that terminating the publication of this data makes it much harder for government to understand the consequences of current policy interventions in the housing market or to assess the case for future reform. And more recently, in March of this year, a former deputy governor of the Bank of England, Charlie Bean, produced this important review of UK economic statistics, and said that inadequate land market statistics potentially hinder a suitable supply response to the housing shortage. And it's easy to see why. many parts of the government hold substantial amount of land, and the decision to release this land for development obviously depend on what you know about the price of this land, and our information is very limited. On the other hand, also for developers, not to know what's the price of land, the exact price of land in different local authorities, this limits the potential of investing in new housing. Now, what do we do in this project? So we try to, using available data, to plug this gap in UK statistics. So the available data that we use comes from the England and Wales Land Registry, and this will be data that is freely available to everyone. And the other part comes from the Ordnance Survey maps. Ordnance Survey is a part of the UK government that produces maps that are commercially sold. Some parts of the government can have access to those maps for free. Others have to buy them. One thing that we haven't tackled so far, but it's interesting to check in the future, is whether the same things that we do can be done with more like open source maps, like OpenStreetMaps, etc. So we leave this for future investigation. And also an optional data set that we will use in the future is information on building costs from the Royal Institution of Chartered Surveyors. So what we do with this information, and I will show you the details in the next slides, we estimate land and structure values for properties for which we see the price, the transaction price in the land registry, and then with all this data we can create local and aggregate land price indices. So to restate again, the basic idea behind this work is that each time you see a house that is transacted, you observe the price, and this is available from the Land Registry price paid data. And what we're trying to do is to decompose this price into a structure value and a land value, and we are mostly interested in the land value. Okay, so let's see more in details what the data looks like. So the first most important, perhaps, data set is the Land Registry price paid data set. This is available on the internet, on the government website, and the data set contains, for the last 20 years, all the residential transactions in England and Wales with price, address, complete address, and date. Now, something that a data set that also comes from the Land Registry, is perhaps less used, are these maps of land parcels. So every time a freehold property is sold, it comes together with a piece of land. The Land Registry obviously have maps of these land plots, and these maps are actually published on the internet, local authority by local authority. So this is a very important element of our analysis. Now, to work on these maps, we need a software, and we use QGIS, of which I will talk more in a couple of slides. But this is what you get when you open one of these files. This is the London Borough of Camden, and I will show you more zoomed pictures later. But these are all the land plots, all the freehold land plots in Camden. Right, so this type of information, this type of geographic information is structured according to this idea, this geographic information system, where all the data is put in layers, and you could have a layer that is about addresses, a layer that is about elevation and shapes, ground shapes, etc., etc. And the way, the software to analyze this type of data is, the one we use is Quantum GIS. Is an open source software to view, edit, and in general work with geographic data. It's a very good software, and one very useful feature of Quantum GIS is that there is you can easily run Python code with it. There is a Python console, and contributors can create plugins that are very useful to automate some tasks that often arise when you analyze this kind of data. Now, I've talked about the Land Registry dataset that we use. I've said the other element are these maps by Ordnance Survey. So MasterMap is the main product. MasterMap goal is to map all the objects found on, well, all the main objects found on the Great Britain territory, and this includes buildings, of course, water like rivers, lakes, roads, etc. Now, it's a very big data set, but we can selectively choose only certain elements of this data set, and for us, what matters are buildings. So this is a snapshot of buildings that are in the Camden area. Now, what's interesting that all the elements in these geographic files come with attributes, and one attribute that is that Ordnance Survey recently started to add to the dataset is building heights. This is super important because if we're interested in the structure value of buildings, obviously the height of the building is something we need to take into account seriously. Right, so we have now, from our two sources, we have land registry plots and buildings. What we want to do, because we have no direct way of putting these two together, we need an algorithm that for each land plot matches a building, or for each building matches a land plot, and we need to obviously impose some condition. And the most obvious one is that for a match to occur, you must have that the building is totally, completely inside the land plot. Now, luckily, there are plugins, Python plugins that do this in Quantum GIS, and therefore we use one of those. Now, obviously, there could be cases where more buildings are inside the same land plot, or more land plots are attached to the same building. But actually, these cases occur very, very rarely. So for the moment, we discard them. So that's the set of Python plugins that has proven to be super, super useful for what we do. You know, this Python functions and programs can do all sorts of things. What we are particularly interested in is merging layers. So we can put local authorities together, and if we have enough power and memory, we could potentially draw a map of the entire, England and Wales, all the land plots and buildings in the entire territory of England and Wales. And the spatial join is to put together, to overlap buildings and land plots. And that's where you can find those plugins. Now, this is the result of matching land and buildings. Again, I will show you even more zoomed pictures later. So in green you have buildings, in yellow land plots, but you do see the boundaries between one property and the other, which is crucial. Sometimes those boundaries are cannot be seen in the real world, so that's why land registry maps are really important. One last thing before we put back this data into the land registry price paid data, where we have a match between buildings and land, but we don't have the addresses of those buildings, and that's what we need to link the building size and the land sizes to the transaction data. We need addresses. Now, luckily, Ordnance Survey has this address-based data set, which is a complete set of all addresses in Great Britain. And luckily, address-based has a building ID in it, which can be linked to the MasterMap buildings. So the match is quite easy. Now, we have addresses for each of the buildings, and we can see whether those buildings, those houses, were sold in the last 20 years, see the price, and decompose the price into a structure and the land component. So in the last part of the second half of my talk, I'll show you some preliminary results from this exercise. One thing that I need to mention before is, now there are two actually methods to get at the land values, depending on whether you have data on construction costs and possibly depreciation of structures. Now, if you have this data, you first estimate the building value. So you know the size of the building. Now there are data sets that give you the construction cost per square meter per floor area of these buildings. There are data sets that also give you information on the depreciation, because of course you need to take into account depreciation. Not all buildings are brand new. Now, if you have this data, you first estimate the value, the structure value of all your buildings, and then when you have a transaction price, you get at the land value by subtracting from the transaction price the value of the building. So that would be the most precise method, but you need data on construction costs. If you don't have data on construction costs, you can still do something that gives you a meaningful answer, and it's the regression method. So the price, we have it. This comes from transaction data from the Land Registry, price paid data. Building size we have either in square meters if you use the plane map, or cubic meters if you also use the information on building height. And we have land size from our Land Registry maps. So by running a simple linear regression, you can get at these two coefficients, beta 1 and beta 2, which represent the implied structure value for square meters and the implied land value for square meters. So this will give you another way to get at those values which are of interest for us. Now, the building cost information, what we have found is that there is the Royal Institution of Chartered Surveyors publishes this data. They come at a cost, but they can be bought. And what's interesting is that they have building cost information by local authority and year. And since we have data on the entire England and Wales for 20 years, this breakdown is super useful. And also they have valuation of depreciated replacement cost. And that's really what we are after, because we don't really want to know what's the value of a building if we build it again new. We would like to see the current value of a building. Now, why is this data out there? Because insurance companies have this information, because they insure structures against fire and other incidents. However, we haven't purchased this data yet, so now I'm going to show you some results with the regression method. And to build an example, I chose these two postcode districts. One is in London, NW5 in the Camden Borough, and the other is in Swindon, SN25. Now these two postcodes are very different. That's why they can make for a good example. On purpose, I've kept for the two postcodes the same range of values on the vertical axis to highlight the differences. Now in Swindon, in SN25, we have had in the past 20 years, in relative terms, many house sales, but the average price in relative terms as compared to the price in the central areas of London has been quite low. At the opposite side of the spectrum, in a postcode like NW5, we have had very few sales. I have to say that I focus here only on house sales, not flat sales, and prices that have been going up dramatically. This is a picture of our geographic data on SN25, but perhaps it's more interesting to see the zoomed version. So this really gets at the heart of what we're doing. So the green rectangles or the green shapes here are the buildings for which we know the sizes, and the rectangles around the buildings are the land plots that are associated with those buildings. Now you see that usually the shapes are quite similar, and the land plot shapes are also similar. However, there is variation in the data. You see some properties that have a big or long garden and a relatively small building, and vice versa. You see other properties with a bigger building, a smaller garden. So this variation in the data allows the statistical regression to estimate a value for that extra square meter of land or the extra square meter or cubic meter of structure, and this is what we exploit. Yeah, this is some scatter plots from the data to get a sense of the kind of information we are working with. Now the first scatter plot on the left is the relation between building area and land area. Now, of course, one thing that jumps out and which is expected is that land area is always larger than building area. This is almost a requirement, a sanity check of the data. Indeed, in the few cases where this doesn't happen, we consider those cases outliers and we drop them. But this scatter plot also highlights one potential problem of the regression method to which we need to find solutions if the problem gets too serious. So there is a very high correlation between building size and land size. So there is a big correlation between two variables in linear regression. It could be that some of the building structure picks up the effect of land and vice versa. So we need to take this into account. The other two scatter plots plot building area against price and land area against price. And that's, again, a sanity check. I mean, we would expect price to rise with these two variables, and this is what we see. Although perhaps with both those variables, we see that price rise with a steep slope at first, but perhaps, especially with land, then flattens a bit towards when we get to big land plots. A curiosity maybe in this scatter plot is that you see some discontinuity at 250,000 in Swindon. That's because of the old stamp duty system. There was a threshold at 250, so it didn't make a lot of sense to price a house at 251. Rather, people would stop at 250. Right. So this is the first really, plain regression that we run. It's just, as I said, price on land size and structure size by year. And what's interesting, we know that the results won't be as precise as we would like them to be without those building cost information that we are collecting. So perhaps what's interesting to do here is to compare the two postcodes and to see if the results at least match our expectations. And I would say they do, because if we first start from structure, we see that structure is more expensive in NW5. And if we look at land again is more expensive in NW5. However, we get the impression that the difference in structure is smaller than the difference in the two land prices, which is what we would expect. The problem here is it seems that NW5 structure prices are picking up, especially at the end of the sample, a lot of variation that is probably due to land prices rather than structure. I mean, we don't see in the general building cost index such an increase in the last part of the sample. So what we can do is to say, okay, building costs, they will differ from one area to the other, But it's difficult to imagine that those differences will have dramatically different trends. So we could impose to tackle this multicollinearity problem between building and area. We could impose structure cost is the same as in SN25 and in NW5. In this way, the shape of the line will be similar, and there will only be a level jump between SN25 and NW5. Now, if we make this assumption, then the land prices in NW5 will pick up all the variation, and this is what we would expect from the theory that we have in mind. Again, obviously there is variation in land prices in Swindon, but if I keep the same range of values on the vertical axis to make sure that I highlight this difference between the two postcodes. And this is I wanted to leave some time for Q&A, so this is my conclusion slide. There is a big gap in UK statistics, UK economic statistics, which is the fact that we don't know anything at present about land prices. There is a solution, is to put together, it's not to collect new data, it's just to put together data that is already out there, and especially merging geographic data using Python and QGIS is a great way to put together information that we have on building sizes and on land plot sizes, and therefore decompose house prices into structure and land. This is a work in progress, and I'm very happy to hear if you have suggestions, comments, etc. Thank you very much. Yeah.
So I work for the Department for Communities and Local Government. This is very much in our area. So the work we share the same issues with the area stuff. I was wondering if you checked your results against the various land price indexes, land price sales agencies online. So one thing that we looked at was using the data from those sources to try and estimate land prices across the regions as well. And it seemed like that would be a good option for being able to test some of the assumptions to see if the model is tracking to real world cases.
No, that's a great suggestion. We'll definitely do that. The thing we already thought of doing is to take this VOA price index, which I'm sure you know about, and estimate our data on this whole range, then check whether in the 1995 to 2010 range we kind of match the same pattern. But yeah, direct land sales is a great. Of course, this is is a great comparison. Problem with direct land sales, as far as I know, is that you don't see many of those in the center of cities, obviously, because land is already occupied by structures. So that could be a problem. But for the more peripheral area, that's the best check we can do. Yes, thank you.
Did you make any allowances for the quality of the structures? Because the price of a house varies quite a lot from something that is in need of modernisation through to sort of luxury.
Yeah, I mean that's crucial, obviously, and so the way I think a good proxy for this quality, I mean one that can be backed out by the data, is the age of the structure. Well, it's one proxy, it's one of the many, and so the Land Registry starts. I mean, as far as I know, we don't have a data set with the age of buildings in this country. I mean, some agencies like the VOA, I guess, have this information, and local authorities have this information to compute council tax bands, but I don't think this information is public. So what we can do is to use the Land Registry price paid data, which starts in 1995. We have an indicator variable which tells you whether the building is new or not. So if something was built after 1994, we can derive the age of the building and then do something. The other thing we can do is assume that in the same local area, the quality will be more homogeneous than between two different local areas, and allow for this level average differences between areas. And yeah, we need to think about, I mean, even more ways potentially, of course.
Can you speak a little bit about the potential commercial applications of this kind of data analysis? For example, could real estate developers use it to spot opportunities in the market?
Definitely. Obviously, I mean, the fact that yeah, many government organizations are involved in this kind of questions. We see this as a public good. So once it's going to be out there, everyone would be able to use it. And then, of course, yeah, other people could use the land price data to infer, to predict things about the future of some local housing markets. So if we manage to do this, so derive land values for individual houses, then as far as I know, that will be the first country to have those values. I've seen papers from the US, they do this for Washington, DC. And one thing that they find, which relates to what you're saying, is that you can, for each house, decompose the price into structure and land, and you have the share of value that is associated to land rather than structure. They find that this has a predictive value on the amount of price increase or price fall that those houses have experienced. So that's super useful information. Yeah, definitely.
Yeah, so you mentioned that there's a big gap in the statistics, but do you think sort of the private companies that you also talked about that sort of indicate the price index and all of that, do you think they do already do this, but you just mean from an open source point of view, there is a lot of scope?
I'm sure big developers and people in the market practitioners. I'm sure they have estimates of land values. Yeah, definitely. So that would be more like a public good, open source kind of approach to the problem. But also perhaps to insert some rigor, not in the sense that we're saying that the values we will be getting at will be the exact ones, but at least is reproducible by other people. So if we make mistakes or we do something wrong, other people can say, do this in this way. Whereas for private companies that estimate land values, we don't know how they get at those values. So. Yeah, so that's in this first phase of the project, that's what we do, because conceptually we still need to think how to interpret the leasehold arrangement, where presumably, there could be a leasehold arrangement on a house, although it's not that common, or obviously with blocks of flats. There we would see in the Land Registry the transaction of the leasehold. But that wouldn't capture the entire land value. So we need to think about that. I'm not sure we can do that. I know, yeah. I know, yeah. No, it's an issue, and the other thing is how to deal with the flats, right? I mean, conceptually, if we sum the value of all flats, then we will have the value of the building, maybe, but I mean, there are many things to take into account, like common areas and stuff, yeah.
You can use the number of address points in that polygon building. How many flats in that building?
That's right, yeah. The stock is not an issue, yeah. How the stock is made this we know, yes. There was
a suggestion and a question. The suggestion is mentioned that the lands in London tend to have buildings on top of them.
Yeah.
You could filter for buildings that are being destroyed just after the sale. I see that a lot as construction for So there's a building, but because they get rid of it, that's more cost than value of the what they're buying it for. And the presentation was super impressive. I like how you dealt with collinearity.
Mm-hmm.
Have you looked at the distribution of land price and how that shape evolves as a way to make sure that your prediction makes sense?
Yeah, so the only other research of this kind I'm aware of in the field of economics is from the US, and they started this, because they wanted to prove the point that building costs are quite homogeneous across areas and over time, even if they grow, obviously. But we in general in the economic in these years in all economic domains we see an increase of inequality, and in the housing market this inequality is in land prices, it's not in structure prices. So say that London has grown at double speed with respect to another area in the UK, then it means the land price have grown even more, and that's something we need to study more. Yes.
Going back to the potential commercial applications, maybe have you looked at the variability of land prices according to your model within the same, let's say, postcode or square mile, to construct some sort of, let's say, Z-score into what's really cheap or rich versus the average of that square mile, so that adjacent piece of land should theoretically be priced similarly.
Yeah.
Is there a lot of variability which could explain opportunities or?
Yeah, I think it's a good idea. Whenever we find variability, we always have to think whether this would be true variability or some kind of measurement error, because obviously we
But if you trust your model,
yeah.
in the end you could say this is the fair value according to model, and then if something is really way out for no apparent reason, it could be either very expensive or very cheap. Right?
Absolutely, yeah. No, that's a good point. And related to this, now comes to my mind, according to many economic models, the optimal tax system would tax land values and not structure. And this is obviously not what we have at the moment. This is just me as an economist, obviously not advocating anything. But in theory, land values could be useful also for potentially in the very far future some new ways of taxing the housing. Are there any other?
Sorry, could you explain how you dealt with the year and the collinearity again?
Yeah. So we run the regression in each year. So we treat each year separately. The way we dealt with the collinearity is we have so for land we have a different coefficient for every year. For structure, we only have one coefficient because we assume that the evolution over the year is the same for all postcodes. Then this only one coefficient, beta 2, maybe beta 1 should be indexed by t, because if beta 2 is the same, is the one that makes your line go up and down, just on a level change, but not any slope change. So basically, we take our structure measures and we multiply them by the building cost index value for that year, and we impose the same coefficient on all those values. That's what we do. Yeah.
Is there enough repeat sales in the Land Registry that you can track like individual properties? This was sold in 2000 at this price and 2010 at this price.
Yeah, there's definitely enough repeat sales in the Land Registry because I've done other pieces of research focusing only on repeat sales. That's something that we haven't thought about, but because presumably you're thinking the piece of land doesn't change, perhaps there's some change in the structure, it's nice variation, etc. Yeah, thank you. Yeah.
So do you have a land price index that is in the presentation?
Yeah. That's the VOA Valuation Office Agency.
No, have you done this in your?
Oh no, we haven't. Yeah, no. We started small.
By postcode instead.
Yeah, well, that's the end goal. So as you can imagine, I mean, we need to automate this more, perhaps using the Python scripting facilities of QGIS. So far, we have been doing only these two postcodes because it's quite, it's been quite time consuming. As we get more experienced, we will automate everything, and that will be, yeah.
Can I ask a quick question? In your regression, how accurate was your predicted price? Do you know how well it fits the model?
Yeah, I don't have that piece of information. I should have it. Yeah. But it's very rough. So as of now, it's not super accurate. Yeah, but it's a good question. Okay, and I'm here to discuss with any of you if you have further questions. Thank you.